Ting, the new way everyone is getting their cell service. No overage penalties, great rates, keep what you do not use, no contracts, and someone will actually pick up the phone when you need support. Use our link and get $25 off your first month's service or your new phone. Just go to tech-zen.tv/ting to save $25. Hello, welcome to episode 40 episodes already of Let's Make It. And tonight, I'm going to do a couple things. First of all, I have no pumpkins or any kind of decorations for Halloween yet. Haven't even gone and gotten the pumpkin yet, although I drive by them fields a lot, so I'm going to stop by this week or weekend sometime and pick up some. And just maybe try to do some carving and some creative stuff. I've actually seen some other creative things on the internet now about some electronic type decorations of pumpkins and things like that, so it gives me a little bit of inspiration. I actually got a cool idea, something I was going to try. We'll see how well it works out. So this week I have a couple things I want to update everybody on, and then in the second half of the show I'm going to show you how to get a smart switch to put images on it and how we read it, and show you some of the things that we're doing with the smart switches in the new broadcast board. Now you can't really tell this from this shot. I mean, you can tell from this shot. Oh, well, you can't really tell, but it's right here. This is the old controller, so I'm not using the new controller. But the reason is actually good news, because I have the new controller out at the people who are going to make the case for me, or the enclosure, or whatever you want to call it. They are going to custom make one for each model that we're going to sell. So they kept what I had as a working model to make measurements and everything. So it's a cool thing that I don't have it here, although I kind of miss it because this thing here is not the greatest, but it works for tonight. So that's good news. Hopefully in the next week or so I can get that and show you what it's going to look like, what the first model we're going to release is going to look like, because they're making that now. All right, a couple other things. First of all, this week I've gotten an Arduino Duo, or Duo, or I don't know, I'll say Duo. Arduino Duo, D-U-E. And the reason I got one of these is because I have a board coming that I've mentioned in the past, and I'm going to show you that board here. And it actually has an Arduino Duo on it as part of it. And actually, let me get over to that website. And this is it. And if you see things that are going to scroll around here, you're going to see that it's really the equivalent. You can get it on a 4 CPU model. So it's equivalent to 4 Raspberry Pis and an Arduino Duo. And it's called an Udoo. And I got notice this past week that mine shipped. This is the Kickstarter project that I backed. Wow, I don't know how long ago. And it's finally shipping, and it's very exciting to me. The main reason it's exciting to me is because I want to possibly use this in the switcher in the bigger models, because I'm using an Arduino Mega for the current stuff that I'm playing with, but I'd like to be able to do some more things with it. I'd like to be able to include some things that are more Unix based. For example, NTP so I can go out to and get a real-time clock into the board. I can use it for controlling timers and other things, so it'd be time specific. I also like to do a couple other service things that can be used across the network that not everybody has in their network, so this device would be able to provide that. Also be able to provide a web interface to maybe do some switching and a few other things, and a couple other things that I've been doing with the cloud-based with the Mega, which works fine, would be a little bit easier with that. So I would take the Duo part of the board and control the switcher, but let the communication up to the Unix side, which is what's much better at communicating than what this is. So the Udoo has basically 4 CPUs for the equivalent of 4 Raspberry Pis and a Duo, whatever you call these things, and they can communicate together. So I could have this part doing the hardware switching part and the other one doing the communication, and separate it up. So some of the bigger things we're talking about doing, that board would work well. And I'm very excited to get it because I really want to play with it. But anyways, the reason I got a Duo or whatever, I'm just going to call it a Duo, because it uses different voltage. We've been working with Arduinos that are 5 volts on a pin. This is 3 volts on a pin. So if you don't test your stuff, you could very quickly blow up this thing. And this Udoo board is a 3-volt board. So what I had to do is, like, the reason I got this is I can start testing my stuff, which should work fine with 3 volts, but I want to make sure. And I'd rather blow up this than Udoo. So that's why I got one of these. So it's a little different. We never worked with one of these before. Now, the Raspberry Pi is a 3-volt board, which I know some of you have found out the hard way by trying to do 5-volt things with it, as I have gotten emails about. But we never really tested out all of our switching stuff. Now, our stuff's basically should run on 3 volts with just changing the resistor. So we're going to try that with this, put a couple boards together and make sure that it works. That's why I got this. So I'll let you know how this goes. This is the first time I've actually worked with one of these, although it looks like it works pretty much the same as any other Arduino. I've already loaded sketches and stuff on it. It just runs at 3 volts versus 5 volts on the pins. All right. So the other thing I got this week is this Arduino Ethernet. So this is, you notice there's no USB on it. The programming pins are back here in the back. And in the middle of this mod, you see this module right here. That's a PoE module. So that allows this thing to be powered by Ethernet PoE. So I'm going to experiment with this as an option for the smaller switchers that don't have, a ton of buttons on them. The more buttons you got, obviously, the more power you got. And this really is not much more powerful than an Uno as far as the Arduino itself goes. So the Uno is a little underpowered for the larger switchers, so this wouldn't work for that anyways. But this would work maybe for the small ones where you just run one cable to the thing and be done with it, and that'd be your power and everything. And maybe we just provide a PoE injector module as a power source for these things, and just make it real basic. Plus the little things we're doing, like this thing I showed you last week. This could actually be PoE based, and you run one cable to it, and that would be your producer's box and stuff like that. So I got some stuff to play with. I'm still trying to figure out the PoE because I don't think it's actually made by the Arduino folks. I think it's actually made by somebody else, and they just put that on there. So I'm a little curious about that, and that's kind of the reason I wanted to learn a little more about them. The program is a little bit different, although probably not that big of a deal. So, all right. So before we go too far this week, I want to go through and do some of our typical housekeeping things. Again, this is episode number 40 of Let's Make It, and we record this show every Monday night at 9 p.m. You can come 9 p.m. and watch us live. You can chat with us in the chat room. We watch the chat room. I have it right here in front of me, and we can interact with you. You can ask questions. We do start the show a little bit early, and you can come in and kind of play with us a little bit. Today we were about 35 minutes early. We were in here, and I guess we consider a pre-show, and we're just doing little things here and there. So, and as people in the chat room can ask questions and interact with us. We love for people to do that. So, definitely love that part of it. If you want our show notes from this show, it's tech-zen.tv, or if you want a shortcut, go to letsmakeit.tv. It takes you right to the right place inside the site to get to the show notes for this show. And if you're on Facebook, like us like our fan page. Our fan page for TechZen TV is facebook.com/TechZenTV. We'd love to have you go in there and follow us, and we could communicate with you and with other things that are going on in the TechZen TV network. We got a ton more shows than just this one, and there's a lot more coming online as we're going forward here too. And this is a good way to keep you updated with what's going on. If you are on Twitter, you can direct message us or follow us at TechZenTV. And if you're going to tweet about this show, make sure you use the hashtag #Let'sMakeIt. And lastly, if you want to follow us on YouTube, we do have a YouTube channel. It's youtube.com/TechZenTV. Click on the subscribe button, and you get notifications when we put up new videos. All right, so that's the housekeeping type of things that we have for this week. And I talked to Bob today. We haven't seen Bob for a while because he's been having some family emergency type things going on. But I talked to him today, and he's going to try to check in with us here in a little bit. So hopefully we're still going with the show when he checks in, and we'll make sure we bring him in. It'd be good to talk to him again and bring him on the show. All right, so when we come back from break, what we're going to do is, last week I showed you the smart buttons and the different ones, and I'm going to show you how we can interact with the smart buttons and some stuff we designed here, and show you what it's capable of doing. It's pretty cool. It's a little bit hard to see on the camera. The camera's very much zoomed in to show you this because it's a very small switch compared to normally the bigger things. We're going to walk through how we do all that stuff when we come back from break. We'll be back in just a couple minutes.
You work hard for your business. Your website should too. No matter what industry you're in, select your customizable high-quality design with professionally written content and graphic elements created for your business. Make changes online whenever you like. Switch your background color, page layout, and text anytime. Add your pictures and logo. Upgrade your website with useful one-in-one web apps. And integrate social media. Upload your photo albums and embed videos. With one click, optimize your website for viewing on mobile devices. Choose your free domain, or you can easily transfer an existing one. Thanks to One-in-One's SEO tools, customers can find you everywhere. One-in-One My Website, a professional website created by you.
When you open up an Audible audiobook, it opens up your imagination. Enjoy a steamy romance while ironing the sheets. Discover an historic battle while battling the bulge at the gym. Visit audible.com/freebooks now to try 2 books absolutely free. Get caught up in a whodunit during a do-it-yourself project. Listen anytime, anywhere with the Audible mobile app. When you're out for a walk, learn how to climb the corporate ladder. Or bring a little magic to your minivan with a fantasy novel. With over 100,000 titles, Audible is an amazing experience that you can now try absolutely free. And just like our books, there's no binding. Our great listen guarantee lets you exchange a title you don't like for another. No questions asked. Visit audible.com/freebooks to download 2 books of your choice right now.
We would like to thank our sponsors for sponsoring us, and if any of them look interesting to you, please go check them out, because through their help, we keep this show growing. And the equipment we use here, not just for the demonstrations themselves, but the video equipment we use and our bandwidth is expensive, and it just helps us to pay for those expenses. All right, so let's move on to tonight's big project. First of all, let's go look at this camera, and I'm going to warn you, I'm going to try not to make you sick by moving around, but it's very sensitive because I got it very far zoomed in. So this is one of the buttons we showed you last week. It's a smart button with the LCD on the front, and I currently have it just restarted. So what you see, let me see if I can get a good picture of it here. It's just a film strip and camera and testing, the word testing on there. All right, and it's on a board that we made, and on the back you see one of the chips we talked about before. It's 23017, and it basically is a 16-bit, I don't want to call it a shift register, but it's an I2C chip that allows us to turn pins on or off or read the state of the pins. And I'll explain why we use this, because we don't use it for very much, actually. This board will hold 2 smart switches, and that chip is an I2C chip. However, this smart button itself is not I2C. It is the MOSI, the part of the Arduino that's, actually, I can show you where it is on this Arduino. It typically rides on these little things right here. No, I've moved it in this example because I don't use the ICSP pins on my boards. I actually moved it down to pins 47 and 48, or 48 and 49, I can't remember, 48 and 49. But so it's the ICSP that is actually being used to control this. And again, let me see if I can get it to focus in. Yeah, it just takes a little while. So it says testing. Now, what I have it set up to do is when I push the button, it goes and it does a mail icon. Actually, technically, it's a box with 2 slashes through it. You'll see that in the code when I show you that. And it turns it red. It may not look really red to you, but it's really red to me. Then I go and draw a green circle, and then I do a blank blue screen, and then I'm going to go back to the envelope looking thing again, and just going to keep going around that circle. So what I'm going to show you is the code that's required to do this. Now, a couple of things about these smart buttons and how they work. The reason we have to have this chip in the back, well, it's 2 reasons really, is the protocol that you use with the ICSP stuff is not specific. It's not addressable. So there's a pin on this smart switch saying switch select. So whenever that is high, it's telling this switch that I'm talking to you. So what we have to do is we tell a pin on that 23017 chip to turn the switch select high on this, and then we send out data down the SPI port. So that's how we know it's talking to it. Now this one has 2 switches on it. So 2 of those pins on that of that 16 are controlling switch select. So like I said, we're not using much of it. Now we are using 2 more pins because the way we're getting the push button back to the Arduino, is we're using this 23017 chip. So when it sees a contact closure come across from pushing the switch down, it sends back an interrupt to the Arduino. That's how we know that a button is being pressed, is that 23017. So basically every switch that we have uses 2 of these. So using that one 23017 chip, we could technically control 8 of these smart switches off of that one chip. So you see, we're not using much of the chip for this one, basically using a quarter of its potential. So it's not, I don't call it a waste of a chip, but you will see some other boards that we have that have more buttons on them, and we can do up to 8 on one chip off of that, because these are basically all getting the same data. We're just turning the switch select pin high for the one we want to talk to. And you'll see that in the code. We actually created a library, a smart switch library, that makes this very easy to do as well. And we'll make sure you get that library as well out there in the show notes, as well as the program we're going to show you. And I took the very first image. Let me go do that. This is what it does when it first comes up. We never go back to testing again, but that little image, I actually found that from somebody else's example of the Smart Switch library. So I took that from there and stuck it into my code, and you'll see that in my code as well. And actually, I think theirs might have been animated. Mine, I never animated it. So you will see that what I probably have in my code is enough for 3 different images to make it animated. Anyways, so let's very quickly hop over to the code. And so I haven't really gone down and commented all this yet, but we'll start right here at the top. We require the wired H because we are using the I2C, so we include wired H. And this is the library we talked about before for the 23017 chip that we created. So this is our 23017.h library. And then we include our new one, which is the NKK Smart Switch.h. Now, let me just say there's multiple NKK Smart Switches, so this is only going to work with this particular model. I'll probably rename this to be the exact model so that if we ever use a different Smart Switch, which I do plan on using from NKK, then we won't get confused. Now, after this is done, I'll talk about some other things that I've found recently as well, about Smart Switches and a few other things. All right, so we come down, and here's what I said. I found this from somebody else's example of these smart switches, and this is the movie logo. And you see that it looks like they have 3 pages here, pages 0, 1, and 2. And I have not actually animated this, so I haven't even tried actually to animate it. So I know it says it's a movie logo and it's animated, but in my example, I did not animate it. So I just used what they could give me as far as an image goes. So that defines the image, and let's come on down here and we go through setup. I'm going to do serial begin, and I can show you why I do serial begin before we go too far here. And so let's see, it just restarted. So I basically have button states, and that's how I can tell, first of all, what button was pressed, and then the state. Each state is basically the different images that are coming up. So that's what you're seeing, is it going through a loop. It doesn't really tell you much. It's part of my debugging. So let's come back in here and look at the code. So we set up serial, and I was, again, to get the working there. So we have to initialize the wire, and then we come in and we do our smart switch. Now, there's a couple of different ways you can do this smart switch. Now, in my case, I didn't want to use the MOSI in the clock from the ICSP pins, so I actually defined them as pins 48 and 49. This smart switch begin allows us to pick what pins we actually want to use. By default, if you just want to use the standard jumpers, then you can just take out 48 and 49. And in our case, the 80317 is addressed as 7. So, and that's actually done on the board itself. We have jumpers on the board that we had soldered in. So I know that it's 7. That's why I made this 7 right here. It could be anywhere between 0 and 7 with that particular chip. And then what I'm going to do is I'm going to come down and say, on board number 7, I want to turn all buttons. I want to set all buttons to the brightness of 7. And I did it twice here, and I didn't have to do it twice. Sorry about that. But you can just take out one of these. So what I'm doing is I'm saying I want all buttons to be a brightness of 7, which 7 is the full brightness. And then I come down and I set the color to white for all the buttons. Right now I only got one button on there, so it doesn't matter. Button all is going to be only that one button. But in the case that I had 8 buttons on that board, I could set them all to a particular color all at one time, which is what this is doing. So here I set the color to 333, which is white. And then I clear the display. And then I wait for half a second. And then I'm going to draw the image. And right here it is. I'm going to draw the movie logo. So you see this draw image. Basically what it's doing is it's copying out the memory into this button number 1. And it's going to center the image. And then I'm going to update the screen. And I'm going to wait half a second. And then I'm going to write the text of testing. And you can see I'm doing it in reverse with the background, and I'm going to center it. So if we go back and we look at that, let me see if I can reset this and go back, and you can see what it looks like. You can see, well, you can barely see it. You see testing is in the center. It has a background, and the text is reversed. So basically meaning that the text is white and the background is black. And it's the word testing. So that's what that was doing. All right. And you see I update the screen. So when I write this text, I'm writing it in memory. So I have to actually do the update screen to push out any changes that I've made to it. And then we'll come down and we're going to loop. And this is where I'm basically looking for the button being pressed. So when you do this buttons equal smart switch button up all, it gives back with basically an integer that gives you a bit for each button, and it's going through the loop and it's going to compare that bit to each button. So you can see right now this loop's only going through 4 buttons. In the case we had 8 buttons, we could put 8 in there. In my case, I could just put 1 in there, and it'd be work just fine. So if the button is down for this particular button that we're going through, which is J, then we do get button modes, and we read the modes, and then you can see right here I say button J because I know I'm in whatever loop in this was pressed, and you'll see that that's what you're seeing on the screen. And then I take the current state, or make state equal to the modes, and I shift it right, J times 2, and then I AND together with binary 1 1. And then that gives me my new state. And you see here I'm printing out what the new state is. And then I come back and I say if state equals 0. Then I want to clear the pixel map. I want to draw the lines. So I'm basically drawing 5 lines. So here's 2 of the lines, 2 of the lines, and 2 of the lines. So these 2 lines are the slashed lines. There's the 2 horizontal lines, and there's 2 vertical lines. And then I update the switch, and then I set the button mode so that I know where I was, what mode it was in. That's how I'm remembering what mode I'm in for each button. And then I set the button color, in this case to red. So 300 is red. And then I come down, and if it's not equal to state 0, it's maybe equal to state 1, then I'm basically clearing all the pixel maps, and I'm drawing a circle. I'm updating the screen, changing the mode so I know what mode it's in, and then I'm setting the button color to green. So remember, this is red, green, and blue. So 3 green is green, and you saw I draw a circle right there. And then I come down, and if it's not mode state equal 1, then it has to be mode state equals 2. So I come back and I say smart switch, clear the pixel map. I want to update the screen, so I want to clear it, and then I'm going to store the mode. so that I know what mode it is. And then I'm going to set to blue. So 003 is blue, but there's nothing on the screen. That's why you see me, because the blue is completely blank. And then I'm printing out the button state, and I'm basically doing get button modes right here. And I'm printing it out in binary, so you can see what the mode is set to in binary. And that's pretty much it. Now here's the animated box. I never got this to really work. I never really went through and did it, but I can do an animated box as well right here. And this was the code that came with the animated graphic that I'm not really animating at the very top. So you can see it's very, very simple actually to control the graphic part of it. And as far as reading the buttons, I mean, they come back in my case, it comes back in as I believe that's considered a long end, because it's actually coming back with 16 right? No, it's coming back with 8 bits. That gives me what the state of each button is. So, and in my case right here, I'm going to go through 4 buttons, but I could make it 8, I could make it 2, whatever we wanted to make it. And I just basically, getting the mode, because get button modes basically reads the value that we're setting at set button modes from the smart switch itself. So that's just an easy way for us to keep track of what state each button is in using this one class. Makes it very easy to do. So you can see drawing on this is actually very easy. And there's a bunch more functions in the Smart Switch library as well, which you can see when you download that. And it's pretty well documented in there, so you should be able to figure it out. And we're always still adding things to it, so yeah, it'll get better as time goes on. And from looking at the other Smart Switch buttons that we have, it appears that we can probably use the same library for most of them. The drawing works very similarly across all the different things. Their interface is slightly different. Some of the OLEDs come a lot different. The commands structure with the OLED switches are a lot different. So the other thing that I've found since I've been looking around for alternatives to NKK is I found 2 other companies, and hopefully have some samples coming soon. I don't know exactly how the smart switches integrate, but I will say their LED buttons are almost compatible, if not compatible, with the NKK buttons, so I can probably use them to swap them out. And the difference in price between them is pretty drastic, actually. And I can actually get an RGB button that, like the old broadcast buttons, for like a quarter of the cost of just the red-green that I'm currently using. So we're looking into that as an alternative. But the one I wanted to mention was they also have smart buttons, and they're like in the $18 range versus in the $45 range. So I'm very excited to see what they have to offer as well for smart switches, because that may be something that in the long term we look at using instead of the NKK buttons. So, and they also have OLED ones as well. So we're just going to get a couple of those in as well and just try them all out and see what they can do, and make sure we're comfortable with recommending them. And I actually found 2 companies that have similar products. I don't know one company's pricing yet. It's been a little bit difficult to get that out of them, but the other one's been very, very helpful, and we have some samples that are on the way. So we look forward to getting some of that stuff as well. And if it requires a little bit of a board design, or we can go RGB, okay, we'll redesign a board. The difference is that you now have an extra pin per button that you have to control, and the 9685 chips that we're using to control the LEDs and the brightness only have 16 pins on them. So if we go with another 8 pins, we have to go to another one of those chips as well. So it basically would double up the number of chips on a board to do an RGB type thing. So we have to weigh that as an option as well. But it's maybe for the higher end things we do RGBs. The chips aren't overly expensive. If you add a couple bucks for a board, I think with the additional color control you have, I think it'd be kind of neat to be able to support that. But we haven't seen the buttons yet, so we can't say for sure that those buttons are even broadcast quality or quality we would recommend that somebody uses. So we'll see when that gets in what we do with those buttons. But something to look forward to, and I don't know exactly when they're coming in. The one company is Well Buying, and they're Taiwan, and the other one's RGS Electronics, which is the one I'm having a little bit of trouble getting some pricing out of. I think we had some miscommunication in the beginning, so I don't think it's anybody's fault necessarily, but just a little bit behind getting pricing and stuff like that from RGS. But they're out of England, so 2 different parts of the world, but they make very similar products to NKK. They both do, And I love NKK switches, but they're a little bit pricey. And even the eSwitch compatibles are still a little bit salty, and they don't feel quite as solid to me as NKK. NKKs feel really solid, which is one of the things I want to make sure that these alternative switches are the same way, because I don't want to put out something that's cheap feeling. I want to make sure that it's very solid. But anyways, that is the smart switches that we talked about last week, and this is just one of the models. I still have the other ones sitting here right next to me, but this is the compact model, which is the one we're probably looking to use, just because it's closer to the size of a regular broadcast button, and it has a real nice feel to it. And so far, it's been working very well. Actually, it was very simple after we figured out a couple of the little tricks to it to get it to work. And one of the things, I don't know if you could tell when you're looking at this, is this ribbon cable is how we're connecting all of our boards. The same ribbon cable goes between all boards, and you can see this particular one has other, well, the camera's kind of tight, but this particular cable has multiple plugs on it, because we can plug in any of our button boards in this chain. And let's go back and look at the Arduino to show you how this is connected. So on the Arduino itself, we have our 5 volts and our ground, which is powering this bus. And then over on this side, we have SDA and SCL. So this is our I2C. And then here is where we defined 48 and 49 to be the replacement of using this ICSP pin for the SDI interface. So we could have used that up there and just use the default pins, but in our boards we don't. Well, this actually goes to the Ethernet. That's how they control the Ethernet, and we don't want to take that from them. So we actually put it down in here on our breakout boards. It just makes it a little bit easier for us that way we don't affect what they're using there as well. So in our code, in our library, you can see that we're doing the SDI on these 2 pins right here. And if you don't specify these 2 pins, it will use these. But like I said, this is being used for both Ethernet and also for the SD card. So we decided to do our own and move it down to these 2 pins down here. But it's a very simple interface. For most of our boards, these 2 are the only 2 that are needed to control read the buttons and can turn the LEDs on and off different brightnesses. But when you get to these smart buttons, they require these 2 right here. This bus has power, has the I2C and the SDI on it. In addition, it also has the joystick return as well, and one other thing that's on there. So basically can go from board to board to board and get most of it onto this. I think the other one's the encoder board that we have that's on here. So we can put all this in this one bus. Now we do have a couple of different buses depending on what it is as well. We have serial buses and a couple other things, but for the most part, we just run this one cable from board to board to board to board. And when you look inside, it's nice and neat and clean, because there's no cables running everywhere. So when we get that case, we'll bring it in and show you what it looks like inside, and actually what the case looks like too. I'm kind of excited to see it, because I haven't even seen the drawings for it yet. They are still working on the drawings. So, all right. So that is pretty much it for this week. Haven't heard Bob come in yet. Let me just make sure I didn't mute him in some way. Oh, what do you know? There he is. Let me go grab him real quick. I'm trying to grab him. It's not working. There he is.
There we are.
Sorry about that. I couldn't get to the thing to come up.
That's all right.
I don't have your video.
Well, am I not sending video?
I don't see any. There you go.
There we go. Well, I've been watching for the last couple minutes.
Oh.
I've
Did you
caught
hear
the
me?
end of the
Did you hear me say we're waiting for Bob? Yeah.
Yes,
Make
and
sure I
that's
did,
when
make sure I
called
didn't
in.
mute him.
Yes.
Okay.
And
Good.
that's it. And that's when I called in. So
Okay. Good.
so I saw the tail end. It looks pretty good how you're using the switches.
Yeah, it's pretty fun too. I had a lot of fun working on that. So, how you been?
I'm doing better.
Hanging in there?
The last few weeks have been tough, but things are turning around. So,
Good.
and I'm glad you're doing better with I2C than I am right now. So,
Yeah, actually, I got I2C working pretty good. I had some SDI issues, but I've worked through them. I just haven't used it enough to play with it. So these chips or these buttons use SDI to get data down to them.
well, I'm still working on my I2C problem, but hopefully by next week we'll have that ironed out. So, should we talk about? I know we were talking about this afternoon.
We can talk about it if you want. Yeah.
Okay, well, the Rainbow Duino, I've got it. I know we've talked about it off and on for several weeks now. I do have it working, although it's the direct connection I have working. I did get the I2C to work just a little bit, and then I went back to work on the direct connection, and now I can't get the I2C to work anymore. So I don't know what I'm doing wrong, but I will get it figured out.
So needless to say, the people that are having problems with the Rainbow Arduino are legitimately having issues with the Rainbow Arduino.
Yes, and I have been sorely disappointed with the documentation. I'm amazed that they didn't have a proofreader read their documentation. I mean, there's really, I don't want to be critical of non-native English speakers, but this was written by one, and it's got gross language errors in it, which is really surprising, and it's hard to follow. And I've found mistakes, and so I've pretty much thrown the documentation I got from seed aside, and now I'm just hacking away at it. And so even the library they send with it, I've made some changes in that code just to get it to display better. So
right. Yeah,
so it's been a painful process, I'm afraid.
Yeah, and just to remember that we had somebody come in and had a problem getting it to work, and was asking us about it. So we started looking at it, and you're having the same issues. So
yeah,
it's not that person necessarily.
No, it's not that person at all. I think once it works, it actually makes a very it's a pretty good display combination between the Rainbow Arduino and the LED that you can buy to go with it. But it is. I'm having a lot of trouble getting it working correctly.
Yeah. Okay. Well, hopefully you get some luck this week and maybe take a look.
Hopefully so. So yeah, we will definitely have a lot in the show notes for the Rainbow Arduino episode.
Maybe we should send the show notes over to Seed.
Well, and that's something else. I've actually reached out to Seed twice now and have gotten nothing back from them. So I don't know where my emails are going, but they're not being responded back to. So.
That's I don't know. That's a little disappointing too.
Yeah, and in both of them, I actually identified myself as being, somebody from the show. So, and telling them that I was going to use this as a demo. So,
okay,
maybe they don't want the free advertising. I don't know.
Yeah, maybe not.
So,
all right. Well, I don't really have anything else for the show tonight. I'm glad to see you call in, though. I'm glad to finally get a chance to talk to you.
Yeah, and I'm sorry it's been a little trouble the last few weeks.
Yep, I understand.
All right. That's all I had. I didn't have anything.
Okay. Yeah, I don't have anything else either. So hang on for a second and we'll close up the show here real quick. Hang on a second.
Thank you.
All right, everybody, we'll see you next Monday at 9 p.m. And hopefully, maybe we can see a Rainbow Arduino if we can get Bob and get to work.
Yes.
All right. See everybody next
week.
Week. Night. For show notes for this show, contacts, and more, go to the techzen.tv website where you can get show notes for all of our shows. We love to hear from our viewers and listeners. We have an email, a Twitter, and a phone number where you can contact us for each show. For details, visit the TechZen.tv website and get the show details. You can also make a video and upload it somewhere like YouTube or Vimeo and then just send us a link. You never know, you may see your video in a future show. You can get all of our shows delivered automatically to your favorite device by going to your favorite podcast website like iTunes and subscribing. Each of our shows also has a YouTube channel you can subscribe to get regular updates. Our shows are also available on most internet radio networks like Stitcher and TuneIn Radio. You can also watch and listen to our shows on Xbox, TiVo, and Roku. You can even find us on your Zune.